Who knows? Hey, how's it going? Hope you're having a fantastic day. I went on a bike ride today, and it's been like 2 months since I went biking. And everything hurts. It was only an hour. But yeah, so that's awesome. I guess it's a good kind of hurt. Speaking of good kind of hurt, I found a royalty-free metal playlist, and I haven't listened yet. Well, let's give it a shot. Hopefully it's actually royalty-free. I found one a couple days ago, and it had like stuff that was definitely not royalty-free on it. This is the, I'll show it here. Rock instrumental royalty-free music called extreme metal. So let's do this. Oh yes, I can do this. Alright, awesome. Hopefully that's not too loud. Oh, I don't like the southern thing. I don't like the southern rock. Yeah, I'm pickle about my rock and roll. I'm picky about my rock and roll. I guess we'll give it a go and see how it goes. I don't know. Not too keen on it so far. Alright, oh hey. So doing a coding challenge today. This one's called Flood Fill, in which we're given a image represented by a 2D array of integers, each integer representing the pixel value of an image from 0 to 65,000. Given coordinates representing the start, and a new color, flood fill the image. So to flood fill it, we take the start pixel and any pixels surrounding it that are the same color as the start color, and then we start flopping them to the new color. This sounds like the problem we had a couple weeks ago where we had to find the number of islands. That problem was harder. It involved us basically doing this kind of flood fill type thing over and over again to try and find each island. So this is very similar to that, and I think this is going to be easy. We have a hint. Do I want to look at it? Yes. Yes, I do. Write a recursive function that paints the pixel if it's the correct color, then recurses on neighboring pixels. Okay. So I'm imagining breadth first or depth first doesn't really matter. I like doing breadth first on graphs or matrices just because it seems more natural to me. I don't know if that's true or not, but I like it. Oh, let me get the chat up just in case. Cool. All right, and yeah, I think that will be good. One thing we have to be careful of is basically we can't revisit a node twice. So, for example, if we've already changed the color, does that matter? If we change to the new color, yeah, it doesn't matter. Doesn't matter. I don't think that's a big deal. Okay, I still want to be cognizant of revisiting nodes anyway, just because I don't want an infinite loop. But this should be no problem. Hey, what's up, RazTubes? Let me fix the chat real quick. Awesome. I'm not racing. Who's racing? Let's see here. Fix the chat. Fix the chat. I'm not racing. You're racing. Okay, gotta hurry up because RazTubes is doing the problem too. All right. Just kidding. I am not a competitive person. It's much to the chagrin of my sports ball coaches growing up. Just don't really have it in me. Is there only one song on this playlist? Flood fill test.kt. Yeah, this looks like a fun one. That's because one of these days I'll make a template. Who are we kidding? I will not ever do that. Wow, what happened to my rockin' tunes though? What the heck? Oh, we already heard that one. Alright, this one's called Adrenaline Rock. Okay. So far, so good. Alright, so we have our image, which is once again an int array. An array of int arrays. It's going to give us a point on that array. So that's start row, start column, and our new color. Alright, so I'm thinking standard BFS. And if it's the color that I find at the start, then I'll flop it. And if it's not, then I'll stop. Also, if I flop that color, I'm going to check my neighbors in the 4 cardinal directions, and that should be good. Say my start color equals my image, and I'm guessing it's rows by columns. Okay. From the center of the, yeah, this example doesn't help. Yeah, I mean, I guess it's just rows of columns. We'll find out. That'll be easy fix. All right. Let's our start color. If I were, I mean, I could recurse. If I do a breadth first, I have to keep a queue, which I don't really mind. That doesn't bother me. It does increase the space complexity, but only by 4 at a time. So I think that's better than potential stack overflow. So yeah, I'm gonna go with it. All right, this playlist is pretty rocking. Feels like 1980. I had enough in 1980 the first time I was there. What am I doing? Thinking back in JavaScript. Hey, thanks for the whatever that was. Like maybe? Alright. I'm still trying to think how I want to do this. I mean, I guess I already kind of said it. Like, if we wanted a queue, the list implements it. Was it linked list? And do we want to have a separate class for this? I guess. For a coordinate called point. Why not? One cool thing about data classes is that I can actually compare equality on another point, and it will compare these values for me, the R and the C, to see if they match. So it's kind of like does the equals override for you, which is nice. Need to double check this linked list to make sure it implements queue. Implements list. Oh my gosh. It's DQ. Yeah, this will work. All right. So we got a linked list, and the first thing we will do is add first a new point for our start. All right, and then while, or do while. Queue is not empty. And in here, we will queue up, or rather get the first item off the queue, and we will queue up its children. if they match the start color. And what else? Then we will change my color. Is there anything else? I kind of don't think so. So let's see here. Get first. Remove first. Oh, I guess the queue. Oh, it does have my points. Yeah, there we go. So, there are 4 children. Hey, what's up, Abdul? I saw you did this one like 5 hours ago. I didn't want to watch it yet. I was just going to do a standard kind of BFS. And looks like I'm almost done already. Just got to kind of check some boundaries. Assuming I didn't miss something. So if SR minus 1 is greater than 0. Yeah, I ended up. So you did the tuple for the point. Yep, cool. I probably should have done DFS and I don't know. I guess DFS you still have to track visited, so yeah, that's a good point. So in BFS with a directed acyclic graph, you definitely have to worry about re-going over items that you've already looked at before. Is that a problem here? I don't know. Let's see. Just do it like this. If you're greater than 1, then we can queue up point for SR minus 1 and SC. So that will be up. We can do down. Seems like there ought to be a better way to do this. Maybe a little helper function. What's TLE? 0, 0, 0 and 1, 0, 1, 1? Yep. Yeah, I'm just kind of used to trying to favor BFS for trees for some reason. And even that's like not usually a big deal. Although it does seem like in interviews a lot of times people ask you when you would do a BFS and when you would do DFS. I think the standard reply there for me is like a lot of times if you know the data is kind of related to where you're at, like in real world situations, BFS is kind of good because it searches closer to itself in the node, itself in the graph. Whereas DFS, if you've got like a really, really large tree or graph, you can go in one direction for a really long time, not knowing that the answer is, tends to heuristically be close to you. Oh yeah, I know TLE very well. I just didn't know the acronym. That's my old friend, time limit exceeded. Let's see, add. And here I'll take a queue, which is a queue. Or whatever it is, a linked list. Let's be explicit. Hello TLE, my old friend. This music is kind of weird. I'm like in a 80s Ghostbusters movie or something, I don't know. Not that I'm complaining. So we take in a point. Whoa. And here, what I was thinking is basically like if p dot r is greater than or equal to 0, and p dot r is less than or equal to, I'm gonna have to pass in a lot of stuff, which is annoying. At least I can get it in the order of things that change. Yeah, that makes sense. I like that rule of thumb. So if a path exists, then use DFS. Shortest path, use BFS. Yeah, that makes a lot of sense. So what point is what changes? And we've got the, I don't know, width and the height. All right. And p dot column is greater than or equal to 0, and p dot column is less than or equal to our width. All right, if that's the case, then q dot add. Add last. All right, why are you yelling at me? Oh, hey, there's a range check. Oh, that's nice. Why didn't it give it to me here? I do love my smart editors. Okay. That looks good. Then we'll add it. All right, so then up here, we don't have to do all these silly checks. We can just say add our point. This is it's going to end up allocating more than we need to, but I think that's not the end of the world. So it'll be so up. Width is going to be, see, I'm assuming it's a square. I said it was an image. I think that's a safe bet. So image at 0.size, sure. And here it'll just be image.size for the height. All right, so that's up, down, left, and right. All right, so there we just added all the children, and now we just actually have to change my state. And yeah, I think that's okay. What about dupes? How do I avoid checking dupes? Yes, good, super good call. Thank you, Sarav. Did I say that right? Let's do it in here, sure. Oh, that means I need to pass the color too. Oh my gosh. This argument has gotten ridiculous. You know how I can avoid passing all of these arguments? I think Kotlin will let me do this. I just make this function, just declare it inside as a lambda. Looks like that'll actually do it just fine. I'll just drop the function right in, and I don't have to pass all that stuff, and I can access whatever I want. Wahaha. So even this, I don't need to create the point here. Why do the allocation if we don't need to? There we go. Even better. But this is going to be a little bit different. I feel like I'm listening to instrumental offspring. And don't let me forget the color. All right. All right. If image R at C dot is equal to start color, then we can add it. But we won't actually set the color until we get to it. Okay, I think that looks pretty good. And then down here, only after I add. Yeah, okay, I recognize this song. It's the White Stripes. This is like tempting me to karaoke. Oh, nobody wants that. I don't even want that. All right. I guess, do I already have the current? What did I actually add here? I added a point. Okay. Sorry, I feel super cheesy with the music, man. This is not working out like I expected. There's a reason why people don't listen to instrumental rock. By the way, when I say that I like to listen to instrumental rock while I'm working, it's not like this. This is not my recommendation. One more case. New color. Let's see. Don't forget to try it later. All right, Abdul. So when you mention edge case 000,011. So what is going on in that case? It's not a square. I'm not sure what I'm supposed to be watching out for there. Okay, so if I understand you correctly, I'm looking at a matrix that's 2 rows by 3. Okay. Okay, R, C, and 1. Okay, yeah, so let's see what that looks like. Let me return image 2. So in that case, 1, 1. Oh my gosh, this is instrumental REM. Oh my gosh. Oh my gosh, one sad tomato. What is current color is same as new color. Okay. So yeah, I come in here and I would set this to 1. What if the current color is the same as the new color? Then I'm just done. So we'd set this to 1. In my case, I mean, I would go next door, I would set it to 1. I would go up, not set it. Oh, but yeah, when I get to this guy, I would say, hey, okay, yeah, good call. Good call. So how do I track visited? I think in the point class we just track, well, yeah, good call. Good call. So what's the best way to handle that? It's like I could almost like tell this thing which direction it came from, but no, that's not good because I'd have to like recursively tell it what not to check. So in a traditional kind of BFS type environment, I would basically keep another track of the node, which would mark it or paint it as a gray or orange or whatever, you know. I was never too fond of that analogy. It just seemed weird. Anyway, so I would basically mark it as visited, and then in here, if I noticed the item was visited, I would move on. So maybe in here, I could keep a separate data structure of everything I've visited. And then if I, go in, or before I add, rather, I could always check that data structure to see if I've been there before. It's a bit heavy-handed, but no need to track visited. How do you prevent that? How do you prevent that? I mean, would you like keep track of the direction that you came from in order to not check it again? Is that what you're thinking? Does that work? Simple thing you can do after line 10. Oh, yeah, good call. Awesome, yes, good thinking. I was about to do some dirty things. But yeah, alternatively, if start color equals the new color, then we're just done. Right? Yeah. Alright, good call. Just save me a big headache. Alright, I kind of just want to go for it. Am I going to regret doing the same thing I always regret, which is typing out a bunch of stuff without testing it incrementally? Runtime error. I thought I checked. So if R is in our rows and C is in our size, image at 0. Sorry, the formatting's weird in the comments. I switched the R and the C. I totally believe that. Do you mean the entire thing? I got R and C wrong? So maybe this should... Here's one way to test it. Don't recommend this. It's not the way to solve this. Okay, line 19. Good, because I was going to feel really bad about that one. If R is in... You're right. Yep, good call. And... Whoa. There we go. Good call. I guess I probably should have tried looking at my problem, see where the problem was to to see what was going on, rather than instantly trying to do some weirdo stuff, which I'm not even sure like what that would have meant. Ugh, again. Yeah, so if R is in... Oh, I think this is inclusive. Is that true? Yeah, I can't check the size. Which looks like Kotlin's got something built in for that. So this until that. Okay. Okay, so that's pretty cool. So there are a couple nice little language features there, but yeah, I like being able to say just is R in indices. Like that just reads really nice. Wow. What is indices? Wait, what just happened? Oh, I pasted instead of Control B. Ooh. Yeah, it's ridiculous. Kotlin's just a nice language for working, and it's fully Java compatible. Even at the file level, you can have one Kotlin file right next to a Java file, and it just works. Yeah, man, if you have to work in anything JVM-ish, I highly recommend it. It compiles down really efficiently. It's just great to work in. I feel like it's really readable too. Like even if you're not familiar with the stuff in it, like any programmer can look at this and, whoa, what the heck did I just do? I don't know what I just did there. Anyway, IDEs are a blessing and a curse. Yeah. Wait. Where are jagged arrays? An array whose elements are arrays, yeah. It is still in Kotlin too, it just kind of hides it a little bit. Yeah. Not very slick. C#'s gotten so nice, man. It's been nice for a long time, but I'm just a fan. Like, give me Kotlin, C# or JavaScript, or give me death. Hey, looks like that worked. Yeah. I'll say I like jagged arrays. I don't love them. Hey, yay, it worked. All right. Slightly worse than average. That's my normal. So here's the best answer. Flood fill. They take the size. Okay. An array of Boolean. That's pretty cool. So that's how they keep track with whether they visited something or not. And then they just, yeah, basically, so it's very similar. One of these days I'm going to pay for a month and just see if, like, just me paying for their faster speeds, like, improves my runtime. Yeah, DFS. Okay, so I tried this once before, and I'm not 100% sure if it's true, but let's try it. I have once heard, and at some point I believed, that the only difference between BFS and DFS is whether you use a stack or a queue. And I tried this once before, and it failed miserably when I tried to just... but you know, it wasn't the stack versus queue thing. It was, I forget what the deal was with the problem. Let's try it. Let's see what it looks like. Yeah, the speed will change. It's crappy. And it does really. Yeah. Let's see. Linked list. I thought there was just a stack. Oh, okay, then it's not add first, it's push. And then here it should be pop. Okay, did that work? Yeah, I think the time I tried to do that is I just had a bad algorithm in general, so I kind of blamed it on my being lazy, which, I mean, it's ultimately the root cause of most problems in my life, but in that case, it was specifically the algorithm. That was, I forget what day that was. It was last month. Oh yeah, that's definitely a bug. I don't recommend. I just had to know if that would work. Hey, all right. So there you go, Sarav. We just changed the BFS to a DFS by changing a few lines. So I'm gonna look that up to see if that's actually true. Let's see here. All right, there we go. So now it's name stack. Let's see how it compared. So, hey, look, it ran faster. All right, let's see. So graph, BFS, DFS, queue, and stack. Yeah, okay, there we go. Draw a small graph on a piece of paper and think about the order in which nodes are processed. How does the order, blah, blah, blah. One of them uses stack, depth first, and the other uses a queue, breadth first. Yeah. Queue can generally be thought of as horizontal and breadth. Stack is vertical. So that's a nice way of remembering it. So depth is associated with stacks, which you also think of vertically. And BFS and queues go nicely together. That's a cool way of remembering it. Oh, here's another funny one. This guy remembers it by keeping barbecue in mind, or this person rather. Barbecue starts with a B and ends with a sound like Q, so therefore BFS is a Q, so the other one must be a stack. Wow, that's funny. All right, so I'm glad that that worked out, and we got this problem done. All right, and now because of me being sore from my bike ride, I'm gonna go ice my shoulder because I'm old and fat, and apparently everything hurts when you ride a bike. So hope you all have a good one, and thanks for hanging out. Adios.